Look at this plot of land. If you want to put up a fence, you measure the outer boundary. That is your perimeter. But if you want to plant grass across the entire inside, you need to know the surface enclosed. That is your area. For SSC exams, we start with the two baseline shapes. For a rectangle, the area is length times width, and the perimeter is twice the sum of those sides. For a square, because all sides are equal, the area is side squared, and the perimeter is 4 times the side. What if examiners only give you the diagonal? You don't need the sides. Use this alternative directly. Area is 1/2 times the diagonal squared. Let's also fix a unit trap. Because you multiply length by width, 1 square meter actually equals 10,000 square centimeters. Nailing down these basic definitions and unit conversions allows you to secure fast points before dealing with complex polygons. Let's look at triangles. The most common mistake here is falling for the height trap. This shape shows a base and a slant edge. That slant is not your height. To calculate area, you must find the true perpendicular height, dropped straight from the apex to the base. If a problem only provides the 3 side lengths, use Heron's formula. You can memorize it using this phrase: happy elephants radiate often nice sweets. That stands for the square root of S times S minus A, S minus B, and S minus C, where S is your semiperimeter. For equilateral triangles, there is an SSC-specific shortcut. If you draw a circle around the outside, the circumradius, and a circle inside, the inradius, their ratio is always exactly 2 to 1. Moving to 4-sided shapes, a parallelogram is simply a slanted rectangle. Notice how skewing the shape sideways doesn't change the base or the perpendicular height. The area formula remains base times height. The rest of the quadrilateral family is defined by their unique features. A trapezium has 1 parallel pair, requiring you to average the bases. A rhombus has 4 equal sides and perpendicular diagonals. A kite has adjacent equal sides. For the rhombus and a kite, you focus on the diagonals. The area is 1/2 their product. Recognizing these physical properties, like whether diagonals are perpendicular or sides are parallel, is the most reliable way to select the correct formula for the problem. Let's put this into practice. Here is a previous year question. Pause the video and try to solve it. Because the perimeter is 50, the length plus the breadth must equal 25. The area is length times breadth, which equals 150. The two numbers that add to 25 and multiply to 150 are 15 and 10. The shorter side is 10. Let's transition to curves. Think of the mnemonic RICE. Radius inside circle exists. This locks in your area, which is pi r squared, and circumference, which is 2 pi r. This diagram displays a circle and an internal sector defined by a central angle, theta. We treat this area as a fraction of the whole circle. Divide theta by 360 degrees and multiply that fraction by pi r squared. Calculating curve values is merely an exercise in applying basic fractions to your fundamental circle formulas. The exam frequently tests composite figures. A classic scenario is finding the area of a circular track inside a rectangular park. Use the step-by-step subtraction method. Calculate the total area of the large outer shape, calculate the inner shape, and subtract. This is your ultimate 2D mensuration cheat sheet. It combines the Rice and Heron mnemonics and the 2 to 1 triangle ratio. It also includes every formula we've covered. Take a screenshot of this exact frame. Regular review of these patterns and practicing the subtraction method on composite problems helps eliminate calculation errors and improves